Well, welcome everybody. I know, it's been a while since I've streamed. Let me know how the audio is doing because I changed things around a little bit. And I think Spoon might be the only one here. Oh, come on. Alrighty, Facecam. Anytime now. Okay, that was really weird, and the mic's right in front of my face. Oh, and I figure I start the stream, and lunch arrives. That any better, Spoon? I was playing around with the equalizer on my mic as well, so. But the big thing is I've rerouted the audio, so the computer audio now goes through my mixing board as well. So I can better control the sound of games and stuff. I gotta change that calendar. That calendar's still in March. There we go. Now that calendar's correct. Okay. Yeah, I'll have to play with the audio on it, because like I said, I was playing with the equalizer on it, and I don't think I got myself sounding good. I just went with it. But okay, a few things that have arrived. So, as you can see, I've got some speakers and some plexiglass. This is eventually going to be a new speaker set that we're going to assemble and stream, but they forgot to send me the electronics part of it. They just shipped that out yesterday. So, that'll be in the future. Along with that, I've got these. I was just testing them the other day. They're analog VU meters. I'm going to mount one in each speaker. And then, of course, I have to ditch the original cord on that and go with something a little better, because that had 1/8-inch stereo for its cord. But my system is all 1/4-inch mono, so I'm going to convert it over to 1/4-inch mono. Those move out of the way. Another thing that came, this is that red, white, and blue flashing thing that I've told you guys about in Discord the other day. It's going to be another... that might get assembled today. I don't know. Depends on if the power supply gets done. And then this other stuff sitting up here is me getting ready for my solar lighting system that's coming in a piece at a time. Right now the only thing that's in is the box to mount the switches in. But for today, we're going to be assembling a power supply, which I've done a little off-camera work. Like I found some standoffs for that piece, and I mounted the main power transistor to the heatsink. Now, this kit didn't come with a heatsink, so I found a heatsink that I had lying around. This is for an old Pentium 4. Probably a bit overkill, but I won't even need a fan for it. Most likely. But what I liked about it was the circuit board fits almost perfectly right on top, and then the diode can go down underneath. So there's that. It also has a thermostat that I shoved in there. Looking at the circuit, I don't think the thermostat actually does anything besides turn on and off the fan, so I might not even need that. See, I don't know what the red, white, and blue flashing is going to become yet. I might just randomly dump the LEDs on the table and just stick them in whatever order. Pardon the munching, I have a grilled ham and cheese sandwich for lunch. Okay. Now there's instructions that came with this that I had to download off the internet to find out about it. And it pretty much tells you the same thing all the other Chinese instructions do. Start your welding with the resistors and work your way up to the largest component. So I kind of figured, who needs the instructions, right? You know, oh, come on out. Okay, I think that's all the parts. We got diodes, big capacitor, some rotary encoders with push buttons, resistors, connectors, transistors, more diodes. I was playing around with this the other night and started bending components and doing things. Like, I mounted those to heat sinks already. We got a potentiometer. Ooh, we got more standoffs. Oh, I know what those standoffs were for. Those standoffs are for the screen. Capacitor. Why do I have a nickel in with my components? Big resistor. I forget what the 104 capacitors are. Oh, that's the other thing that came in, but I've already put them away in my box of parts, is I've gotten a whole bunch of just random components that I ordered, like capacitors and resistors and transistors, and I think I ordered a set of diodes too, that are all just nice and neatly arranged in component boxes. Because you can never have too many just random components around. Well, I guess you could, but I think that's the point at which it starts taking up a full room. Okay. I think we got all our components here. Okay. Alrighty. I guess we should start by finding out values of resistors. I mean, the big one's obvious. We're not going to mess with that one. I don't know. Does this show up on stream at all? Kinda. Okay. Obviously more than 2K. More than 20K? Wow. This is a biggie. This is a 47K. Okay. And doesn't work. That one does. Okay, so there's my 47K resistor. Uh, 21, so this is probably a... This isn't even a K resistor, this is a... .21. Not a 10K, it's not a 470 ohm. Ah, this is my 220 ohm resistor. I have one of those, okay. 20. I could sit here and read resistor bands, but as you know, I hate 5-band resistors. They're a pain in the butt to read half the time, so... Alright, are these the 10K or the 20K? These are the 20K. Which means these are probably the 10K. Yep, those are the 10K. 470 ohms, I'm guessing, on these ones, just by the number. Yep, those are the 470s. 4.7? Or are these the 47K? These are the 1Ks. So these are the 4K7s. Yep, these are the 4K7s. Or 4.7K. Depending on what part of the world you're in. Although I think here in the US, the only ones that we do 4.7. Alrighty. Now that I've got resistors identified, time to start putting components in. After I take another bite. We'll start on the main board and then we'll do the control board. Okay. Well, we'll start with the smallest component first, which is this diode here, which is a 5-volt clamping Zener diode. It goes in there. Might need my helping hands, don't know yet. Roll of solder that's pretty sad, but still works. Okay. Where did I put my clippers? Well, since we're still, since we're already doing diodes, let's do the next smallest diodes. And probably at the same time we can do resistors. So these are 4004 diodes. Kind of just an off-the-shelf jelly bean diode. Okay, what do we need for resistors? I need a 4K7. Need 2 4K7s. Bend that over. That one over. There's one 4K7 in there. The other 4K7. And sorry for the lack of stream, guys. It's just been between work and then kids and everything else. Haven't had a chance to really stream. Okay. 1K. I need a single 1K resistor. Which is you. put in... It's a 4K7. I did. I put a resistor in the wrong spot. Good thing I noticed that. I put a 4.7K resistor in a 47K resistor spot. Okay, so this is a 1K resistor. Things would have gone when I plugged this in if I hadn't have noticed that. You guys probably would have thought it was funny. There's the 1K. Well, I know I need a 47K resistor, so... Pardon the noise in the background. It's the littlest brute spawn being noisy. Which is one of the reasons I haven't been able to stream. But I'm like, screw it, I want to stream. Oh, I need the other 1K resistor. Single 470 ohm resistor, which leaves me 3 for the other circuit board. Do. Okay, and I need a single 10K resistor for this board. And that should be it for the resistors, other than the variable resistor. Double check, make sure. Yep, don't have any other resistors, so I can flip that over. Go to town soldering. There's my solder. Hey, you. Look, littlest brute spawn. You gotta be quiet if you're in here. I'm streaming. Luke. Doo-dee-doo-dee-doo. Make sure all my solder joints look good. And clip, clip, clippity, clip, clip, clip. Okay. Now let's see, I think my next tallest component is these guys, the little capacitors. And you don't have to, but I'm being OCD on this and making sure that all the number labels are facing the same direction on these. Because on these ceramic capacitors, they're not polarity sensitive. That didn't work. And judging by the circuitry, these just look like they're a bunch of decoupling capacitors. So that as you change the voltage on this controllable power supply, it doesn't, you don't get spikes. I think one fell out again. Having a heck of a time on these. idea. Bend those slightly to hold the cap in. Hey, that worked. There's the end. It's not the end I'm looking for, but it'll work. That's the end I'm looking. No, that's not. Is that the end I'm looking for? That might be the end I'm looking for. I don't know. This poor roll of solder has been dropped so many times. Now, I realized after buying this thing that I don't know if I have a 24-volt AC power supply. So for testing, we might just have to fire it up on a 16-volt and see what happens. We just might not be able to get it to its full voltage level. Okay, so that's all of those in. Which is taller. I think the caps are slightly taller. This is an S904 transistor. And an S905. I can't remember off the top of my head which one's which, but one's an NPN, the other's a PNP. Transistors are in. .22 nanofarad capacitor here. Yep, I was wrong. Transistors are slightly taller than the capacitor. PNP versus NPN spoon is what they call the junctions inside a transistor. So a PNP is positive, negative, positive, and an NPN is negative, positive, negative. And basically, to take away from it, a transistor is an electric switch. An NPN transistor takes a positive voltage Carbon Gnarly, thank you for the host. Anyway, so yeah, an NPN takes a positive voltage on its. Is it there? Oh, it takes a positive voltage to trigger it, and an PNP takes a negative voltage to trigger it. So. And that's on the base. Now, yeah, because each transistor has a collector, a base, and an emitter. Let's see if I can see this here. Positive, okay. Thank you for the follow. Let's see. Oh, it looks like we may have gotten rated. I'm not sure. I didn't get an announcement of it. I just see that our viewership went up, but thank you for the follow. I didn't catch the name, so let me pull that up here. Leb TV Live, thank you for the follow. Okay. Alrighty. So, let's see, what's my next tallest component on here? Probably those big diodes that go over here. Which well, welcome everybody for coming on over here. What I'm doing today is I am assembling. What I do is I buy these random little kits off of sites like Alibaba and Banggood and all that, and I just assemble them. Right now, what this is a programmable power supply that I bought. It's got all the components for it. It didn't come with its own heat sink, so I scrounged through my box of stuff and found this old Pentium 4 heat sink. It's probably a bit overkill, but I may not even need a fan to cool it. So, yay! Now what they're doing with these diodes is instead of using a bridge rectifier, they are literally using 4 diodes. And what a diode does is only allows the current to flow in one direction. So when you take an alternating current signal that is reversing back and forth, it converts it into a direct current, meaning it flows from, well, depending on which side of the coin you're on, you know, some people say it flows from negative to positive, others say the current flows from positive to negative. We're not going to get into that argument. But literally, the way these are arranged, when that alternating current comes in here, it only allows positive to go, you know, the positive to go to one side and the negative to go to the other. And they're just using discrete diodes instead of a bridge rectifier because if you go onto a place like Mauser, these things probably only cost like 7 cents a piece, whereas a bridge rectifier is about I've seen them as cheap as 12 cents a piece, so. But they aren't very high current like this setup is. Yeah, exactly, Leb. The reason they use the discrete diodes like this is it's cheaper because, you know, when they're buying in bulk, these things are less than 7 cents a piece, and the full bridge rectifier for probably something that can handle the current that this is going to handle is probably, you know, maybe almost $1 for the rectifier that these would use. So that's why they tend to use the discrete. Takes a little bit more time in soldering, but will probably, because of the large size pads and the large size leads on these, I probably will have to hold my soldering iron in here longer. Don't mind the son over there. He's playing, I think, Gary's mod by the looks of it. Yes. Okay. How's that flowing on there? It's flowing on there pretty good. Okay. That's warm. We'll solder one side of these diodes and then we'll go back and solder the other so I don't heat the diode up too much. You can kill electronic components by getting them too hot while soldering. But I want to get a good fillet on both sides of this. Come on. Okay. That one cooled down too much while I was soldering it because my solder stuck to it. There we go. And you don't want things to happen like that because then you get what's called cold solder joints, which can be a pain to troubleshoot later. They're easy to fix, they're just hard to troubleshoot because it'll be an intermittent issue that it'll seem like it's working fine and then your device will heat up and then it'll stop working. Okay, I'm getting good fillets on both sides. Now time to solder the other side. Yeah, I've noticed that I don't in doing electronics streams lab, I only get about 10 viewers or so. Let's see. Hast du mir Deutsch here? I am trying to learn German, Spoon, but I don't know it yet. Spoon here is a fellow German lab, and I've been trying to learn German, but, you know, work, life, everything it gets in the way. But I caught the gist of what he was saying. Let's see. Yeah, see, and I don't know what you said, love. I'd have to actually go translate it. Oh, okay. Yeah, it is kind of unusual on that me and the guy who inspired me to start streaming, which I'll go ahead and link his channel. He's taking a break right now because he's moving, but short 4 kilobytes short. He does some cool gaming and stuff. His creative streams are usually him coding, if you can call it. He does coding. It's more like bashing snippets of code together until he gets something to work. But hey, he gets something to work, so that's the plus side. Me and him, well, he's the one that inspired me to stream, and he had a lot of Germans in his channel. And when I started up streaming, a lot of those Germans came over here too. That. Okay, this guy. A couple of these didn't get a good fillet on the other side, so I'm flowing in more solder. Okay, got a pretty good fillet on both sides of those. So, those leads are still hot. Hi, Kevin Klink Muller. I am assembling a power supply that I bought off of Banggood. Which I just clicked something there. Because, you know, for my channel, what I do is I buy these little kits that come in a box or a bag. Like, I've got this one that we might do later. It's a bunch of flashing LEDs. You know, they're like $4, $5. I think this one was $8. And I assembled them on stream. And while I'm assembling them, I tell you a little bit about the electronics that go on in it. So, like this, I just got done doing basically a bridge rectifier out of discrete diodes that takes the AC voltage in, which is alternating back and forth, and converts it to DC current. But ultimately, when this is all done, this is a programmable power supply. Yeah, I order from them all the time, love, and so far in the 70 plus orders that I've gotten, the only thing that they've done to me is I ordered this speaker set a while back, but as you can see, this is all it came with. It came with the plastic to encase it and the speakers, no electronics. But, you know what? I contacted their tech support. They're like, hey, take a picture of the shipping label and what you received and we'll send you what you missed. So they shipped that out yesterday. So hopefully soon those parts will Oh, micro soldering. Yeah. I do a little bit of SMD work around here by hand. And Kevin, thank you for the follow. I might have to get my other clippers because my clippers don't like that. Yeah, those won't fit down in there. Yeah, in fact, I've got a clock that I gotta put together, Kevin. I don't know where that went. Oh well, it was just a lead. Yeah, I lost one of the leads, but that's okay. I'll probably step on it with bare feet later. That's the thing about my carpet here. It's great at hiding things, including dirt, so I don't have to vacuum it very often. Yeah, but as for like the MacBooks and everything like that, I do occasionally help out friends who bring me their laptops that like the power or charge port is not, you know, the laptop's not charging anymore. It's because they broke the power charge port and stuff like that, so. I also do work for Honeywell, and I have if you look through my past streams, I have a couple where I was building things for Honeywell for a project. And one of my other fellow Germans isn't here right now, but Jinx helped me out in the coding on that one in optimizing it. Oh, why am I doing that? Because I've got another one of these JST connectors that goes over here. Yeah, and coming up here soon, I keep hitting the F1 key with my cord. Yeah, I've ordered a bunch of stuff to do a solar powered lighting system for when I go camping. Now, when I say camping, I don't mean like in an RV or a camper. I go dry camping in a tent. And I've got a big awning that we set up. You know, we got several of us have awnings that we set up in the kitchen area, and I'm building a solar-powered lighting system for that for those awnings, so that we, you know, can have light while we're cooking at night. Yay, more Germans! See, and that is why I plan on eventually learning how to speak German, is because it seems like I get a lot of them in here in this channel. Okay. This is higher, gonna be higher. Alright, let's put in this big shunt resistor. Actually, I kind of want to stand that shunt resistor off the board. Yeah, I did not complete that one, Leb. That's still going to be a work in progress. But as one of the things in my channel that I'm going to be doing the JSON on an Arduino for is the Arduino bot there. He is, and actually I can show him to you here. If we come over here to, let's see, let's do this one. And, oh, nope. Wrong one. Wrong scene. This one. Oh, come on. I'm having ever since I updated to the new version of OBS, I'm having problems with my cameras and switching scene. If you see him right there, that is Arduino bot. He is an actual Arduino with an LCD screen attached to him that sits in chat. Oh, I guess I'm not on break. Oh, and Mr. Wells has joined us. Welcome, Mr. Wells. You're tormenting Spoon again, I see. Thank you, Spoon. Spoon just generated. You know, you can actually see him do things in chat. And I gotta start moving my philodendron. I realize it's starting to block my shot. Okay, let's switch back to the workbench here. There we go. I am using IRC directly. I basically took the code for connecting to to like a telnet service that they give you in the examples of Arduino, and I rewrote it to connect to an IRC client. So I basically kind of modified their telnet client into an IRC client. And actually, let's see if I remember right. Is it SRCE? Yeah. I actually do have the source code up on Dropbox. Now, everything's in there except for my OAuth codes and stuff. But I do need to work on him and get him better, and that's why I want to learn how to do JSON on an Arduino so I can actually use WebSockets to tie him into the Twitch API. But it's still probably going to be an IRC client at its heart. But ultimately, the first reason I want to do that is, so right now I'm using, you probably, if any of you are streamers, you've probably heard of it. I use Streamlabs for my alerts system right now. And ultimately, I would like to have my alerts built into my own bot kind of thing. Okay, just getting a couple of connectors on here. Looks like it's about time for the... That actually sounds a little loud coming from my computer. Okay. Yeah, that would be great, Leb. I am always willing to, to accept assistance on this thing, because I mean, I know coding. I've done, you know... Oh. See, and I'd like to get rid of Night Butt, too. Because he's a pain in my butt. But I have him there for spam links. I was thinking about adding RevloBot to the mix, but the reason I didn't is, well, because the day I was thinking about adding him to the stream was the day they announced that they were going to stop him. Okay. I'm bookmarking this right now, Lub. Okay. There we go. I went ahead and bookmarked it. Yeah, and I've seen some of those libraries, and in looking into it, I think that's going to be what I have to do to get any more additional features on Arduino Bot than just simply regurgitating command. You know, regurgitating responses to commands you throw at him. Okay. Getting down to the end of this board. I think next we'll do this guy, but like I said, I don't know how hot this guy is going to get during operation, so I want to stand him off the board. To do that, I'm just going to stick a little standoff in there as a spacer, and then we'll extract that standoff after I'm done here. And that's one thing you guys should always do when you're doing boards like this that have big power resistors, which I'm assuming, let's see, that's the output, comes from there, oh, comes from the trying to see if there's a current sense on this, maybe. I don't there must be just using it as a current limiting resistor. So we're doing this. What's up? Okay, I will keep an eye on your GitHub, Leb, and if I end up using anything from your stuff, I will definitely get, you know, give you the credit that, hey, Leb's the one who created this, so. But, yeah, so they're using this as a current limiting resistor, which so it's going to get hot during operation. So the best thing to do is you notice how I left a decent sized gap between the circuit board and the resistor. You do that for two reasons. One, it allows for plenty of airflow around this resistor as it gets hot, but also then it doesn't scorch your PCB. because I have, in the world of security, I have seen so many times when manufacturers just slam those all the way to the PCB, and then you got a nice dark spot right around it. Let's see, is this the... Okay, this is a 7824, so this is a 24 volt voltage regulator. On its own heat sink. We will solder the heat sink first, and the legs of the transistor. Or transistor. Voltage regulator. And what this does is it takes whatever voltage is coming in, whatever the DC voltage is coming in from the system, and regulates it to a constant 24 volts. Which I'm assuming, let's see, judging by the tracks on this, what that does is we got the voltage coming in from the output. So this is the big output transistor that we can vary the voltage through the control panel when I get that built. It comes in here to the 24 volt, and then that powers the 24 volt fan, which is right here. And then it also comes over here and does the 5 volt voltage regulator, which we'll solder on in a minute. And then that 5 volt powers all the control circuitry. And again, Michael is tormenting Spoon. That's a typical thing that happens around here. And eventually Spoon might start throwing trout back at him. Yeah. I don't know, Spoon, do you still stream at all? Or have you stopped doing that? I just realized something, and it's probably on the floor. One of my capacitors fell out because I didn't solder it. And if I can't find it, I have to. Okay, one of my little ceramic capacitors went rogue and fell out, but that's okay because I have spares. I just got to get to them. This is my box of goodies. Well, I'm still following you, Spoon, so whenever you do start streaming again, I'll watch you. Okay. 102, 103, 104. 100 nanofarads. No, Mr. Wells, it does not have candy inside it. It has a bunch of electronics in it. Like, I dropped one of these little guys on the floor. Can't find him because he blended into the carpet. But that's why you, whenever you're doing electronics, you always have random components, because you never know when you're gonna blow one up or lose one. Actually, candy-wise, we don't have any candy in the house right now. I ate the last of the M&Ms yesterday. I just realized, you know what, I should have been wearing my Mauser shirt today. I've ordered enough parts from Mauser that they were doing, or they sent me an email one time, hey, do you want a free t-shirt? And I was like, sure. Over there in Germany, you guys probably go for J-Car instead of Mauser. Shipping's probably a little easier. Or wait, no, J-Car I think is Australian. Never mind, I don't know what you guys use over there in Germany. Don't like how that's sitting up. Okay. Yeah, J-Car just popped into my head because I've been catching up on EEV blog and Dave Jones lately with his. I like his new silver play button that he customized with the Nixie tubes. Okay. Make sure I didn't bridge anything. Okay, I think the only thing left that I'm gonna mount to this side of the thing, because the main diode and the thermostat are supposed to solder to this side as well, but because of the size of my heatsink, I was going to solder them up from below. So let's see, make sure I get this in the right polarity, otherwise things will go bang. Yeah, if I'm going, Yeah, Leb, if I'm going for just random things like my collection that I've got started here, like all of these. So I got my, random transistors, my random electrolytics. You saw the random ceramics, my DuPont connectors, my random voltage regulators and LEDs. Those all came from Banggood. But if I'm ordering something specific, I'll go to Mauser. Or, if I need something right away, we've actually got an electronic supply house here in the greater Phoenix area. And it looks like my daughter decided to join us. Yeah, like this. This all came from my local supplier, because this is for a work project. Doing security for at one of the high schools coming up. I need to make a bunch of little of my adapter boards again. Which I think there's a stream on it. You might not be available on Twitch anymore. You might have to go to my YouTube channel, which I archive everything on. But it's what I've got is, on Ademco alarm panels, their status is output, armed, disarmed, or in alarm is output in positive 12 volts, and the indicator system that my company decided to go with requires a shunt to ground, so I had to come up with a circuit to do that, which it's really simple, and I just wrap it in heat this is obviously on a breadboard broken out, but it's a 100 ohm current limiting resistor for the gate of a tip 31C, and it's just tied to ground. Well, thank you, Lib. Yeah, right now my YouTube channel, though, like I said, is mostly just I use it as an archive for everything that's going on here. Eventually, if I get time and the patience to actually build my intro and outro, I might actually start making videos specifically for YouTube. But, things get hectic. Alright, let's put these standoffs in here. Now this thermostat that I'm going to be installing on this, I don't even know if I need it, to tell you the truth. Because looking at the circuitry, all it controls is the fan. But I'm still going to solder it up in case I need to add a fan to this later. The problem is I don't have any 24 volt fans right now. Everything I own right now is 12 volt, so I'll have to order one if this thing gets too hot. But with the size of that heatsink, I don't think it's going to be a problem, because it's designed for a heatsink that goes in that footprint right there with a fan on it. And I'm putting one on that's like 4 times the size of what it's designed for. Holes in this board aren't quite big enough for the screws that I have for the standoffs that I have, because these standoffs didn't come with the kit either. Well, see you, Leb. I'll see you around if you stop by again. I don't know how often I'll be streaming. This one was kind of a, I just want to stream today. I was usually doing it on Wednesday nights, but, you know, like I said, work and everything has been hectic. But have a good sleep and see you around. Okay. Now comes the big moment. Getting all of this stuff to line up and stick through their proper holes. Okay, there's the thermostat. There's that. Okay. Now, I've been debating on whether to trim those or not. I don't think I'm gonna trim those, only because... Ow, you know what I forgot to do? And this is exactly why I don't want to trim those. I forgot to clean the other side of the board before I... soldered this down. Solder wick time. See, I got to talking and completely forgot. So what I was going to say is I don't think I'll ever trim these off, because just in case I ever have to unsolder them. Which now I'm ironically having to do because I forgot to clean all the gunk off the bottom side of this board. Left over from the flux inside the solder. Which that's not working too well. Whoops, I cut the thermostat wire and that melted it a little bit. Yeah, I'm just having to heat it up and wiggle it out a little bit at a time. See, if this thing ever if that transistor ever goes bad, what I'll probably do is just cut the leads off and pull them out. You know, pull it off the heatsink that way. 'Cause this is just a pain in the butt. Oh, that was my finger that I just got with the soldering iron. That smells really good. Too bad you guys don't have smell-o-vision. This is not coming off. Lifted a pad, damn it! I'll have to see how badly I damaged it when I get this up. I might be lucky, it might not be a pad. Okay. Got it off. No clue if this thing still works. We'll find out. One thing's for sure, I think I lifted a pad, so I might have to do some repairs on this board. Oh no, the pad's still there. to do that one from the other side. I'm going to check that to see if I damaged that pad or not. Okay, good. I didn't damage the pad. Yay, no damage pad. Okay, now let's clean off the gunk. As I get isopropyl alcohol all over myself and all over my desk. So, what I found works great to get the odd bit of crusty flux off after soldering. This is just a nice stiff bristled toothbrush. I think I bought it at Walmart for, it was a 3-pack for $4. Actually, I don't even think it was $4 for a 3-pack. And then some isopropyl alcohol. Except I keep squirting the isopropyl alcohol all over the place. And I use a microfiber cloth to wipe it off, but and that's why I cleaned that, because I just noticed that this solder joint didn't solder very well. And that's the ground for the output. There, that's much better. Although I have noticed on some of these Banggood circuit boards that you get, the isopropyl alcohol will actually take off the solder resist. So you just have to watch that on cheap circuit boards sometimes. Wires back in their holes. Kind of centered in there. Okay, I'm flashing a little bit here and I dropped a few frames. We'll see if it stabilizes or if it does it again. Wait a second. I just thought of something. Crap. I can't believe it did that. I just soldered that transistor, the main device in upside down. I even looked at that like 3 or 4 times yesterday. So let's unsolder it again. Oh great, now it won't unsolder. But what I realized is that thing's in upside down. Because the silk screen is for if the device is mounted on this side of the board. Not if it's mounted on the other side of the board. And I match the silk screen on this side of the board. So yay, redoing work yet again. But I'm glad I caught it now. Okay. So, this is designed to mount like that originally. So what I gotta do is I gotta mount my board like that with the, yeah. Darn, so it's not gonna fit neatly on there. Oh well. Good thing I saw that now, and not when I plugged it in. Oh, come on, Twitch. Okay. There's no way to nicely fit that on there, is there? Because it's going to be coming out of that side. I mean, I could flip that over, but then it doesn't heat sink properly. Greetings, Jinx! You missed a fellow German who also is into Arduinos and trying to get WebSockets and JSON and all that to work with them. LebTV left a few minutes ago. That's okay. I blame Twitch. Okay. So. That goes that way. It doesn't seem right. Okay, so. If it's that way, okay, so those. Then, yeah. So yeah, that's the way I gotta do it. Okay. Ah, okay. But I still blame Twitch, because, you know, Twitch is always at fault for something. So, Janks, what I'm doing right now is, this is a power supply that I'm using an old P4 heatsink to cool the main, I don't know if that's a voltage regulator or tristor or whatever that is, but basically the main component for the voltage regulation. But I had it all together. I had the main board all together, and then I realized I had this guy soldered in upside down. So it would have gone poof if I had hooked it up. So now I'm redoing that. And then we'll get onto the control board. Yeah, sorry. I kind of want my thing to work right. And it probably wouldn't have been an earth-shattering kaboom anyways. It probably would have been more like a pop and then a puff of magic smoke. If you wanted an earth-shattering kaboom, go watch Big Clive's channel. He just did a thing on one of those wind-up detonators. He even scared some cats. Okay. So this isn't going to be as pretty as I originally thought it was going to be, but that's okay. Because when I was looking at this last night, I'm like, oh, perfect! You know, the board's the same size as the heatsink. I'll just arrange it so the heatsink is squarely under the board. Never done that live, personally, Jinx. Don't like how that's just hanging there like that, but it is what it is. Maybe I can rotate. See, I think I know that story a little bit, Jinx, in the fact, or I mean, Spoon, in the fact that Jinx couldn't turn it off because of the RAID controller that they were using on his RAID array. I might have to go get my big screwdriver here in a minute. My electric one. floor swallowed a screw now too? There it is.
This thing swallows everything.
See, yeah, Jinx, I just assumed it was part of your, rated, file, the file server that you built in university. And that your RAID controller didn't have a battery in it. So you couldn't shut down the thing, shut it down, or you'd lose your RAID. What I assumed when you said that. So what I'm doing right now is I'm just trying to find a good position to put these supports in so they're supporting the weight of the upper board, not the leads of this voltage regulator. Yeah, the heat sinks are generally live. It means voltage, unfortunately, in a lot of those things. Which I should probably mention about this one, that... Well, maybe I should actually do that, because I thought about it. This, if I just bolt this to this heatsink is going to be live at whatever voltage I feed in here, which might tingle pretty good. Ooh, that's flexing the board. Nope, that won't work. mount this on here where it's gonna... I mount that right there. You have that brace there, that brace there. Yeah, this one wouldn't hurt as bad, Spoon, because this thing is only going to be powered up by 24 volts AC, but still... 24 volt AC tingles. I don't like tingling. Although it will wake you up in the morning. So. What, you don't want to get tasered to wake up in the morning?
No.
My son's no fun. Honestly, I would not really taser my son. I just joke around with him about it. Okay, I just saw flickering there for a second. I don't know what happened, but I assume I'm still alive, because my preview says I'm still alive. Okay. I wonder if my computer's getting too warm because my video's starting to flicker is what's happening here. And where did my Sharpie go? Did you steal my Sharpie again? Yes, you stole my Sharpie again.
I didn't!
My son stole my Sharpie again.
No, I didn't! I didn't!
Okay. Yeah, I'm just getting this weird video flickering thing, and I keep dropping down on my kilobits per second. So I'm going to go be right back while I go get some power tools. Hopefully we don't lose the stream while I'm gone. So enjoy the music for a moment.
I'll be watching as I'm waiting for Just Cause 2 to download. Install, I mean.
Oh, that's the problem. My son's downloading something off of Steam, so Steam's like, ooh, bandwidth, mine! Open heart surgery. I like that description of working on a computer live. Okay. And now its face cam's being derpy.
I'm sorry, I wanted to play Just Cause too.
Well, I think part of it's also heat in this room too, Jacob, so it's not all just you. I was just picking on you. Alright, so I had drilled a nice hole and done all that yesterday to kind of prep for this, but it's in the wrong place now. So now you get to see me drill the hole anyways. In hindsight, I probably shouldn't have done that on the glass desk. What do I need? I need 7/64ths, I believe it was. I think 1/8 is just slightly too big. Yeah, 1/8 is just slightly too big, so I need 7/64ths. I really need to get a cordless drill.
Yes, you do.
It's low on my priorities list, though. Because I don't very often even use this thing for work. And they bought it for me. I think I use it more for home than I do for work. Okay. Going slow and easy. Anytime you're working with aluminum, you just want to go slow and easy. Because if you go fast, all you're going to do is start melting the aluminum to your drill bit. Because it'll get too hot. And literally start fusing to your drill bit. These Pentium 4 heatsinks are pretty thick when it comes to aluminum. Through. Clean off the drill bit. Unplug the drill because I'm done with the drill. drill bit back where it belongs. Grab a slightly bigger drill bit. Just by hand, deeper the aluminum here. Keep that one out. I'm hearing owl coming from the other room. If it persists, I may have to go investigate. Okay. Fan, stop blowing this way for a minute while I clean up the aluminum shards. Now I'm hearing stop it, so I may have to go investigate, guys. Be right back again, because I gotta make sure my kids aren't killing each other. And then I love it. I go into the living room and ask them, "Oh, what's going on?" "Nothing." "Then why was somebody saying ow and stop it?" "I wasn't saying ow and stop it." Kids. Okay, back to this. This is a rough spot. My kids think just because I have my headphones on means I can't hear them. Okay, there it is. Bird again after we're doing the tapping. Alright, we're good. Put the drill bit back in here. Time to get some heatsink grease. I'll do that in a minute. A little heatsink grease in this guy. Yeah, sorry, Spoon, I was drilling a hole. Okay. There we go. There's the main power supply board with its heatsink. Like I said, that heatsink's probably overkill for this, but it'll work. Okay, up, bonk. The fan can come back this way. Now that I'm not trying to scoop up aluminum shards. Hang on. I don't know what you two are doing, but separate now. I can hear you yelling at Luke all the way in there. Oops, I forgot to mute my mic. I don't know if you guys heard me yelling at my kids. Okay. Oh, I'm not quite done with the main board. I've still got the thermostat to install. Well, they keep screaming at each other, fighting over something, and every time I go out there, there's nothing going on. So it's like, I'm done with you, separate. Like I said, I don't think this thermostat does anything other than control the fan, but I'm still going to install it. There. Now the main board's done. Now I get to do a bunch of resistors. Start with the 220 ohm. Let's move on to the 470 ohm. So let's see if I can figure out what these resistors do. Okay, so these resistors that I'm putting in, these 470 ohm resistors, are pull-up resistors on the rotary encoders. Or are they pull-down resistors? Well, they go to the LCD screen. They go to pin 13 of the Atmel. And they go to the rotary encoders. Yeah, not 100% sure what those ones do, because they like loop through the LCD screen. Unless they're using the LCD screen as a ground, which would be weird, but okay. Okay, next comes, let's just do the 10K resistors, which it looks like most of those go on the let's see. Yeah, they go 2010, 2010, 2010, 2010. So what I'm thinking all of this does is this whole resistor grid right here is the resistors that they shift in and out to get the value of resistance for this to control its voltage. Why that's up on this board and not down on the main board, I don't know. But I wasn't the engineer on this thing. So 10Ks first. Knew this was going to be a tedious part about this board. Whoop. Yeah, I'm gonna say it was my son downloading Just Cause that was making my stuff go goofy. Because it's fine now. And he's playing. Of course, he's playing without the volume.
Yeah, I'm playing from.
You know, you could... Do you know where your headphones are anymore?
No, basically I broke them. If the cords are hanging around my neck, I just chew them.
Yes, my son is hard on electronics.
Chewing a lot of rubber things.
Okay, all the 10Ks are in. Now time to do the 20Ks. Okay. These color bands look identical on the 20Ks that they did on the 10Ks. So now I'm concerned. Okay, so yeah, that is a 20K. What I'm thinking is probably one's violet and one's red. And that's why it's hard to tell the difference. Yeah, and that one's a 10K. But the color codes are just so similar to one another. Ah, I see what it is. One's red, black, black, red, brown. The other one's brown, black, black, brown, red. Or brown, black, black, red, brown. So. The red looks like brown. Which is, again, why I hate the 5-color resistors. Because they're blue and it's hard to see some of the colors on them sometimes. Yeah, my guess with this is they've got, well, we can probably look at this here. So this side here goes all the way over to that one. Just that one ties to a pin on the AT. Okay. Okay, so yeah, what it looks like is one side of this whole resistor pack ties to +5, the other side ties to ground. And what they do is they shift where they shift where the ground point is along it to adjust the resistance. And that in turn controls the output. And they're just using the direct output pins of the Atmel chip. To sync the minimal current required to ground. It's going to be a lot of soldering here in a minute. Okay, now time's for a lot of soldering, because that's a lot of resistors. So, you few people that are here, I don't know if you're aware, but I signed up for a Patreon account. Haven't got any patrons yet, but I'm also, I don't know what to give away, do for goals. I'm at a complete loss for that kind of thing right now. I mean, obviously, when I am playing video games on this channel, if there's a chance to put somebody's name in the game, patrons will obviously get the first dibs at that. But beyond that, I don't know yet. So, if you guys have got any ideas, let me know. I mean, I have an idea for one, I just am not sure the level, you know, the level of patronage that I'm going to put it at yet. But I am thinking that anybody who pledges to donate more than, you know, at least a certain amount to me, I am thinking on making them those little computer glitches. But of course that'll be a one-time thing. Yes, Spoon. Again, I haven't decided at which level, but at a certain level, every patrons will get one of these guys. Which means I'll have to get more googly eyes because I'm out right now. But I have plenty of those chips that just sitting around. Okay, all my resistors are in. Well, you've already thrown some at me in the form of games and I believe a donation, Spoon. I'd have to look down below to see how much again it was that you donated to me. You lost your pistol?
Yeah. I can't get my pistol back. I'm out of ammo of this.
Alright, I'm not familiar with Just Cause 2. What's the key combination to select weapons?
Well, I can just scroll down.
Oh, you can use the... Oh, scroll wheel?
Yeah, but I don't have.
Oh, you probably threw your pistol then. Well, see, the problem with that, Jinx, is right now the only options I have are CenturyLink or Cox. And Cox is the best one. Now, I might be able to upgrade to a business account in Cox and maybe get a little bit better bandwidth and dedicated bandwidth. Oh, it's the number keys. 1, 2, 3, 4. Nope, not working, Spoon. Then again, my son might have changed things on that too, so.
No, I didn't change anything. Oh, there we go. I don't know how that happened. Probably just by clicking. I just clicked a bunch of times. And just run. Hey?
Yeah, he's in a situation... Oh, well, okay, yeah, I could do that. Or the other thought is I could move to Provo, Utah and get, Google Fiber.
I don't have a grenade.
There should be a box around there somewhere with grenades in it, Jacob. Yeah, and the only reason I would contemplate moving to Provo, Utah to get Google Fiber as opposed to anywhere else it's offered is because I have family that's in Utah, so. At least I'd have an excuse to move there other than the internet.
I have my pistol now.
Yay, my son got his pistol back. Okay, time to solder in sockets. Trick when soldering in IC sockets or ICs themselves, which I don't recommend soldering ICs directly to the board. What you do is you do catty corner. So I did that one there and that one there. And then you double check and make sure that it's flush against the board. This side's not quite flush, so I'm going to just put that up with a little pressure. There we go. Now it's flush against the board. Same thing with these single inline. I just tack one on and make sure the rest are down in. Then you can go to town on the rest of the connections.
Okay, I better get out of here quick. Sorry.
My son's commentary on games sometimes when he talks to himself.
I did it.
I've contemplated sticking him on here, letting him play a game while streaming it.
Yeah, let's see how that will do. how do you agree on a face cam? I'm probably gonna be fine.
Well, if you were that shy, I could do it without the face cam, Jacob.
I would rather have it with no face cam.
Beginning to think, that Winamp's random isn't very random because it seems like this song always follows the so it's always that's, the last song and then this song and ow! That is stuck in my thumb.
Is there any way to actually just play around? Or is that just us three?
Well,
'Cause they're going
if you don't I think it's Just Cause 3 is the really open world one. I think Just Cause 2 is kind of linear.
I can't skip any of the levels because on one of the level on this level I'm going into
I don't know, that the Just Cause games in my list, Jacob, are just because they were in a pack that I bought. Let's see, I pay for 50 down, 12 up at almost $90 a month. This is probably gonna kill my internet here. Oh. I would show it to you guys, but it shows my IP address, so I don't want to do that. So, woo, Streamception. it's behind everything. Wink. That is my speeds right now, while I'm streaming. And I just closed chat. Yay, me! Okay, there. Got chat back up. Alright. I think a lot of my streaming issues, though, Jinx, comes from my computer itself, considering how old it is. Because this computer is almost... The motherboard, I think, just turned 10 this year. It might even be 11 years old. When did the 6-core AMD come out? Because that's when I bought this thing. Okay, that little potentiometer that I just soldered on there, is the contrast dial for the LCD screen. Because all of this is going to be hidden under that LCD screen when this is done. You and I, okay, so this guy goes in here. This guy goes in here. Yeah, see, I pay for, like I said, I believe it's 212. So 200 down, 12 up. And you saw what I'm getting. I'm getting about 180 down and 11 up while I'm streaming. And my kids are watching Netflix in the living room, so... Ooh, hey, it says Lady G is watching. Hi, Lady G. Redoing computers, that's always fun. I get to do that Wednesday for work, because they're finally giving me a new laptop. And I think the new one that they're giving me has Windows 10 on it, I'm not sure. But luckily, most of the hard work is done by my work's IT department. All I have to do is take them my old laptop and say, here, And they do the file transfer for me. Brute Wife just got home. Oh, speaking of which time... Oh! Unless I want to stay up late, I might have to actually take another break here and go start my laundry. Ah, okay. Yeah, as it stands right now on this computer, I've got 3 hard drives. I've got one 500 gig drive and then 2 2 terabyte drives. And the 500 gig drive used to house Linux, but when I reinstalled Windows 10, it kind of ate the grub loader, and I haven't been able to get back into it yet. I need to reinstall grub on it. And then Windows was on a 500 gig partition on one of the 200 terabyte drives, and then the rest of that 2 terabyte drive was for my program installs like Steam Library and that kind of stuff. And then the other 2 terabyte is my random junk drive that I throw everything in because I'm a digital pack rat. I throw nothing away. Okay, not quite fitting. I kind of need that chip. That chip is irreplaceable. Yeah, I don't have anything bigger than a 2 terabyte drive yet, so I don't have to worry about that kind of situation. But I say that yet, because on my upcoming computer, I hope to have a decent sized drive in there. Okay. Here's a trick with soldering screens like this. So, plug the connector in. I'm just going to do one side of these. Little standoffs. And then you literally just drop it on there like this. And it holds everything in place while you solder it. Well, I usually only typically solder because I don't want to damage the connector underneath. So solder that one. Solder this one. Now I should be able to unplug that. It's perfectly lined up. Sassy Jacob. I'm doing that thing again where I'm soldering down towards close to me instead of in the middle of the screen. You guys need to remind me not to do that. Okay. The little display is done. Can be plugged back in. Click. Oh, whoop. No, it can't quite be plugged back in yet. Because I've still got this connector to solder on. So I need to... So, this one is G. So that's the way I need it. Let's double check. G to G here, right? Yep. Oh, come on. AST connectors are a pain in the butt sometimes. There we go. I'm still trying to think if I have a 24 volt AC power supply for this. Oh, you can download disk space now too, Spoon? I thought you could only download RAM. For some reason, when I scrubbed this board, it went all sticky. So I had to use some water. And now it's not quite so sticky. Like I said, sometimes on these cheap Chinese boards, when you use isopropyl alcohol on them, they do that. They'll go sticky. And I think it's the solder mask. So there's the completed power supply. Now I gotta think if I've got a 24 volt AC transformer floating around. Oh, well, crap. Don't we all, Jinx? Does that still have a power cord attached to it though? Yes. Where is that power cord going? Oh, hey, even more solar panels. Or, not solar panels, lights. Okay. There's that guy. Okay, so what I'm doing, you can't really see it, it's off screen right now. I have a really big, it's a 12 amp, 24 volt DC power supply up here that sits in my window because I don't really have any other place to put it right now. That that I am going to use as my voltage source for this. I would move this thing down so you could see the power supply, but it's that big that I don't want to move it. Yeah, I would say anything throwing a smart error becomes high priority, Jinx. Okay, where's my in? Now here's the thing most people don't realize about AC driven devices. While this says that it's AC, it's going to be also driven off of a DC power supply. Like this. Because it literally goes straight to a rectifier after it. I would just use a 16 volt one, but in assembly I saw how it's wired, that it goes from here through the bridge rectifier, through the capacitor, to the 24 volt voltage regulator, to the 5 volt voltage regulator. So the 24 volt regulator needs 24 volts or more pumped into it to output the proper voltage to get the 5 volt regulator to work right. So if I don't feed at least 24 volts into this system, then I'm not going to get the 5 volts out needed to drive all the control circuitry. I'll get a proper 24 volt AC power supply. I think I have a couple floating around somewhere. I just don't know where to dig them up right now. But yeah, on any electronic device that says AC only in, but it has a bridge rectifier like this, you can pump DC into it. But the exception to that is if it's an audio circuit. Audio circuits tend to need both the positive and the negative generated by the AC. Alright, here goes nothing. Let me...
Is it gonna blow up?
Nope, but I got a light.
You got a light.
Hey! I just gotta tweak the...
You got it working.
Yep. You can see it's set for 5 volt. Well, you can't really see that. It's set for 5 volts at 150 milliamps is what the output's set for right now. So let's get a voltmeter on that and see what it's really outputting. Because I'm assuming that's what that voltage pot is for, is to fine-tune that. Let's go ahead and just set that to 20 volts. Sorry, Spoon, I built it correctly. There's no earth-shattering kaboom. See, it's outputting 4.7 right now. Let's see. In 24.5 volts, okay. Out 4.7. See if tweaking this pot. Okay. That pot doesn't seem to do anything. Oh, that pot might be adjusting the control voltage circuitry, so Let me double check that and make sure I didn't over voltage anything. Yeah, see, 5.11. Okay, so that doesn't control that voltage, so it's got to control the output voltage somehow. So, yeah, this is the fun part of a new power supply is calibration. And I think, yeah. Remember how I told you guys that this thing was going to be live at some voltage? So I've got the ground of my voltmeter hooked to the ground of the system right now. If I stick that on there, getting 23 volts on the heatsink. So yeah. That is a potentially hazardous thing that I'll have to remember on this unit. Or if you're building it yourself, just be aware of that. That the heatsink will be live. Okay. 4.58. It's going down. Okay. Alright. It is set for 5 volts. The voltmeter is outputting roughly 5 volts. It's actually doing pretty good. Let's see, let's wind this thing up. Okay, with 24 volts in, it looks like the maximum it can output is 22 volts, which is fine. Well, that's what's nice about this one, Jinx, is this isn't live at mains voltage. This is live at whatever voltage that you put in, which in this case is only 24 volts DC, which at 24 volts DC, I can only get the output up to 22 volts. Okay, at 12 volts, the voltage was a little off, so I reset that. 1, 2, 3, 4. I like how responsive it is and quick in changing voltage. It's a nice little kit. Yeah, well, that's the other thing too. Is if I drag that power supply down that I have sitting in my windowsill jinx, that one does have a heatsink on it that's referenced to the 120 or 240 that you feed into it, which is why it's sitting up there in a windowsill instead of on my bench. And that heatsink is not getting warm at all. Of course, I'm not pulling any current through it. Yeah, nothing's getting hot. So that's definitely a good sign that nothing's getting hot. See, what I need now is I need one of those constant current loads. Oh, I can turn it off. What's the maximum current that it... Maximum current it can do is 2 amps. Okay, that's good to know. Now I was reading the instructions and I think what I just did was just set it so by default it comes up in off. Okay, let's test that. So I set it for 12 volts and 150 milliamps. Blue. Yep. Okay, so I set the default so that it comes up at 0 volts at 0 amps. So the next time I turn this thing on, if I have it hooked to something, it won't blow something up. Now let's see if we can put a load on it. Nope, I just set stuff on top of my mouse. What I got here is this is just a an LED strip that I've been playing around with for my solar lighting system. I probably won't end up using this one. I'll probably end up using a different one here. Something was warm over there. Okay. So we got a LED on there. Let's wind this up to the 12 volts that it needs. And it's pulling more amps than it should. Okay. So, it's hard to see on screen, but because of the LCD that this has got, I might replace the LCD on it. I don't know yet. But according to this, those lights draw 830 milliamps. Is anything getting hot yet? Yeah, there's some warmth on that. Let's do some current limiting. Let's limit those LEDs down to 35 milliamps, or 350 milliamps. It's yelling at me that there's an overload, of course, but the light's still lit. I'm just trying to stress test this to see if I actually need a fan on this heatsink or not. I don't think I will. Yeah, because I don't know if I like that white on blue. But ultimately I want to mount this in a case of some kind. So what'll probably happen is I'll get a 24 volt transformer and a box to mount this in, and this will be mounted in the front of the box like this with the knob sticking out, and then banana jacks down below it, and then the transformer in here, and then just the mains cord coming out of it. Wow, that thing's really struggling, that light, at that level. Yeah, I'm only letting it have 10 milliamps. But again, I'm doing this to try to see if things get warm. So that's a cool little power supply. Yay! And oops on the having to redo it, but and that's in there. Oh, what was I gonna do? I was gonna see if that fan is on right now or not. Congratulations, I just tangled that in with my headphones. There we go. What shit is this? So the fan's not on right now. Yeah, the fan's not on right now. And this heatsink is not heating up at all. I may have to find something that's a bigger load to test it further. I'm trying to think if I have anything that's a bigger load. It's an empty box. Oh, hey. I found out what happened to my dry erase marker.
What the?
Don't know how it happened, but I found it. I've been looking for that for a while. I figured my kids do it.
How is that possible?
Yeah, Jinx. I didn't expect this to be overly warm, considering the size of the chunk of aluminum that I have attached to it as a heat sink. But I kind of just wanted to make sure, you know, that it was going to function without a fan. And who knows, I may get a fan for it too. And the fan will probably never turn on because this thing is so chunky. Alrighty. Well, that's the power supply done. It's gonna take... Okay, yeah, there. It died pretty quickly. So yeah, I'm not sure what I'm going to do, 100% what I'm going to do with this power supply yet, but it just looked like a cool kit and it was on sale. I think it was like 50% off when I bought it. So it's like, ooh, you never have too many little power supplies floating around in your electronics lab. But I am going to take a quick break. I'm going to get my laundry started. And then we'll see if I've got any other project. Well, I've got that flashing light project to put together. And, oh, I've still got this clock that I got to do. So, we'll see when I get back. So, be right back.